This video is the continuation of calorimetry. In this video, we are going to do some exercise on the calculation based on calorimetry. Okay, so let's see what the example is. Let's say I have a piece of hard aluminum. I don't know what temperature it is. I know that it's 10 grams. When I put this aluminum, and by the way, aluminum is specific heat capacity, it is equal to 0.897 joules per gram degree Celsius. If I put that piece of metal into a cup with, let's say, 500 grams of water, okay, it will be 500 grams of water. And by the way, specific heat capacity for water, it is C of water. This is C of aluminum. C of water is equal to 4.184 joules per gram degree Celsius. Okay, so when I put the piece of aluminum, when I put a piece of hard aluminum here, the temperature changed from the initial temperature, let's say it is 25 degrees Celsius. Okay, and now it changed to 25.2 degrees Celsius. Okay, my question is, what was the temperature of this aluminum? Okay, so the first question, let's see if we understand the question. We have a hard piece of aluminum. We do not know what temperature it is. We just put that piece of aluminum into 500 grams of water, the water that was at room temperature, and after I put in the metal aluminum, it increased from 25.0 to 25.2 degrees Celsius. The question is, what was the original temperature of the aluminum? Before anything, we should know that after we put in this piece of aluminum here, what will happen to the aluminum? The aluminum will release heat and will drop the temperature. What will be the temperature it dropped to? Well, the final temperature of the water is 25.2 degrees Celsius. That means the final temperature of the aluminum will be also 25.2 degrees Celsius. Okay, so let's see how we can approach this problem. We know that the heat that is absorbed by water, it will be the same amount of heat that is released by the aluminum. So let's try. The heat that is absorbed by water, that is equal to mc delta T, where m over here is 500 grams. C, that is this part, so multiply by 4.184 joule per gram degree Celsius. What is the delta T over here? Delta T, it is 25.2 minus 25. So delta T equal to 25.2 minus 25.0. That is equal to 0.2 degrees Celsius. So I put 0.2 degrees Celsius here. Celsius can cancel out, gram can cancel out. So what I get is, I have 500 multiplied by 4.184 and then multiplied by 0.2. So I get the heat that is 418.4, that many joules. Okay, so that is the heat absorbed by water. The heat absorbed by water, it is equal to the heat released by the aluminum. Okay, so I'm going to say the heat released by aluminum will be equal to the same formula, m of the aluminum times C of aluminum times delta T of aluminum. The mass, okay, let me put it here. It will be 418.4 joule. That will be equal to, the mass is given is 10 grams, equal to 10 grams multiplied by the C over here, 0.8 0.897 joule per gram per degree Celsius and multiply by delta T. Okay, if I do that, what I will get is my delta T will be, so delta T will be equal to 418.4 divided by 10 and then divided by 0.897. So what I get is delta T, it is 46.6 degree Celsius. Okay, let's see. That is the delta T. Okay, if that is a change of temperature, and by the way, we know that the initial temperature is higher than the final temperature. So let's go down a little bit. So what will be my initial temperature of the aluminum? Okay, so initial temperature plus initial temperature, well, in this case, it would be negative. So let me put it this way. It decreases is a exothermic reaction. So it decreases. It decreased by, and minus the delta T over here, 46.6 degrees Celsius. That would be equal to the final temperature of 25.2. Okay, so T initial would be equal to 25.2 plus 46.6. What I get is 71.8. Okay, we have to be very careful here. Although the heat is always equal to that, sometimes it depends on how you approach the problem, because we have to remember that the heat of the metal plus the heat of the water altogether will be 0. Okay, so if you think that way, then you have to put a negative sign over here, because the way I do it, what I did was, I know that the initial temperature was higher. That's why I use 25 and I add 46.6 to it. Okay, if you think like a mathematician, you always have to put in this equation. That means over here, Q of water, okay, so Q of water should be equal to negative Q of metal. Okay, if you put that in, then you're going to get this one. You don't have to worry about the signs.